Alright, welcome to the Moodle tutorial on how to complete the square. Where this actually came from is from the geometric representation of FOIL. So a lot of you guys have been using this geometry method where you FOIL, and I think it's a really good idea. And if you haven't, here's a quick reminder of how it works. What we did is we just put, for example, if we wanted to do x plus 4 times x plus 4, we just like that, we just put the x and the 4 on the edges like this, and the x and the 4, and then we found the area of each square in order to do FOIL. So this would be x squared, this would be 4x, this is 4x, and then 4 times 4 is 16. I think you remember doing that earlier in the chapter. When I add it all up, here I have x squared plus 8x plus 16, so we have the whole FOILed out version for that right there. Well, a problem that people started dealing with is what happens if one of the corners is missing. So in a sense, what we're going to do is we're going to work backwards. So here's what they would tell you. They would say, I know that this box is x squared. And they're also going to say, okay, I know that this is a 5x and this is a 5x. And now the question is, what number would complete the square? What number is down here like this? So really, you know, this right here I think is pretty easy. We could figure it out, but they would give it to you in this form. X squared right here plus 10x like that plus, and then they want to know what number would complete the square. Well, it's pretty easy to see that this is an x and this is a 5 and this is an x and this is a 5. So the number that would complete the square is a 25. That's essentially what we're doing here. There's going to be a little bit of a trick to it, but that's essentially what we're doing. We're just trying to find what's this magic number, what is the corner that's missing if we want to complete the square. So here's what we have to think of. What are some perfect squares that you know of? Maybe pause the video quick and just think of some perfect squares. Some that I think of are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. You get the idea. Those are your perfect squares. Well, we're going to bend the rules a little bit and say a perfect square doesn't have to be a number. So for example, x squared would be a perfect square. We're going to say that x minus 5 squared is going to be a perfect square. So, like I said, we kind of bent the rules a little bit. These are obviously perfect squares, but we're going to say that these are perfect squares as well. So the next question says, can binomials or trinomials be perfect squares? And the answer is yes. So here's what we're going to do, is take a moment. Let's see if you can FOIL these in your head. So the first one I have is x plus 1 squared. See if you can FOIL that in your head. So pause it and see if you can figure it out. When you FOIL this, you should get x squared plus 2x plus 1. So here's what we're going to say. We're going to say that this right here is a perfect square. That's what we talked about before, is that these can be perfect squares up here. And if that's a perfect square, well, this is equal, so that's a perfect square as well. Okay? Let's try this now. Let's see if we can do this one in our head a little bit trickier. See if you can FOIL that one in your head. Okay, we're going to get x squared plus 28x.
John Liverance, please come to the office. John Liverance.
John Liverance, you're messing up my Moodle video for Pete's sake. Plus 196, like that. So that is also a perfect square. See if you can FOIL the last one in your head, and then I'll tell you where I'm going with this. We should get x squared plus 20x plus 100, like that. Okay, the idea behind this is that I want you to be able to recognize perfect squares that look like this right here. I think it's pretty easy to see that x plus 1 is a perfect square. But I want you to be able to recognize this longer polynomial as a perfect square. It's not so easy to do, but there's a pattern that we need to be able to find, and we'll look at what that pattern is in just a second. Well, the question is, how is this related to vertex form? Vertex form looks like this: y minus k equals x minus h squared. And if you can see, the right side of your equation is a perfect square, and that's where we're really headed with this. Okay, let's look at the next page 1 second. Let's see if we can fill in the magic number. Well, here's what we have here. If I have x squared plus 14x, I want to know what number would complete this, so it's going to be one of those perfect squares that I talked about. Well, if we want to look at the geometry of it over here, let's kind of look at that. well, I know this is going to be an x and this is going to be an x. And I'm going to take this number and I'm going to divide it in 2 because this has to be a 7, because I know that this will be x squared and that this will be a 7x and this will be a 7x. So I divide it in 2 because I know there's 2 squares that it has to fill. So now the question is, what number would complete the square? Well, 7 times 7 is 49. So the magic number here is 49. Now what I want you to do is I want you to take that. This is a trinomial, and I want you to scrunch it back down. Scrunch it down so it looks like one of the perfect squares on the other page. So for example, what I want you to do is I want you to take something that looks like this trinomial on the page before, and I want you to scrunch it down so it looks like this x plus 1. So you're going to, in a sense, do your FOIL backwards. Same thing here. I would like you to take this one, and we're going to scrunch that one down, and we'd scrunch it back up into x plus 14 squared. So on the other page, if we're going to do this, see if you can figure out what that would be. If I have this trinomial right up here, like this, and that's a 49, what would this be if I scrunched it down? Pause it, see if you can figure it out. Okay, hopefully you figured out it's x plus 7 and x plus 7, so this is going to be x plus 7 squared. Well, my hope is that we start to get really quick with this, and that we can just do it quickly. So right here, see if you can do this one right in your head. If you want to use the geometry like we did over here, that's fine. You can go ahead, but hopefully pause it, see if you can figure it out. Hopefully you got 121. Pause it again and see if you can take this trinomial and scrunch it down into something that's in parentheses like this. See if you can figure that out. It's going to end up being x plus 11 squared. Now if we're going to, I want to find an in general pattern. What's the relationship between this number here in the middle and this last number right here? So this, if you remember standard form, we have ax squared plus bx plus c. So this is ax squared plus bx plus c over here. And I want to know what's the relationship between these. Well, if you look, maybe you can figure it out what the relationship is. What we're going to do is take this middle number, cut it in half, and square it. So we'll take b, cut it in half, 1/2, and we're going to square it. So we're going to have 1/2 b squared.